Hiya. So typically, as soon as I manage to get more space on my phone, the video I'm going to make is going to be extremely short, of course. So this is for the second part of reflection, and it is a very short section. And really it's about the difference between specular and diffuse reflection. So I'll just write up here, reflection part 2. I've just realised I need a ruler and I don't have one, but I'll steal something else to use. So looking at the core questions for this part of the lesson, the first one is, what is diffuse reflection? So diffuse reflection is when light, well in this case light, reflects or bounces off of an object, but the rays of light that bounce off are reflected all off at different angles. Therefore, you can't see your reflection in that object. So when you look in a mirror, that would be an example of specular reflection, because you can see yourself in it. Maybe like a lake, you can see yourself in it. That would be specular reflection. But can you see yourself in the moon? No, you can't, because that is showing diffuse reflection. Okay, the only reason you can see the moon in the first place, which is actually covering one of the core questions, is because the sun's light reflects off of it and then enters our eyes. So that's how we're able to see the moon, and that's how we're able to see anything, because light reflects off of that object and reflects into our eyes. So I'm going to draw two little diagrams to show you what I mean. So I'll draw specular first. Because one, it's easier, and well, that's really the main reason. So I need to use this as a ruler, really. So if this is my surface, and let's pretend it is a mirror, therefore do the thing that makes it look like a mirror, sort of. I'm going to have my incoming ray of light, has to be a straight line, remember. There we go, hitting my mirror. Up here, I'm just going to draw my eyeball. There we go, there's the pupil. And if you remember correctly, what I should be doing now is drawing a normal, and I'm not going to draw it with a ruler, even though I should. See, that's what happens when you don't do things with a ruler. It's roughly going to look like that. Therefore, going back to the previous lesson, whatever that angle is needs to be the same on this side. And I should use a protractor to measure that, but I don't have one on me. So instead, I'm going to do it roughly. There we go. That's reflecting onto our eyes. But there's not only going to be one ray of light given off by an object. That's what we've been drawing so far, because it simplifies it. But there's actually going to be more. So if I draw another one just here, and another one here, then again, they are going to reflect off like that. Again, I should be drawing the normals, but you can imagine what they would look like for yourself. So this is specular reflection. Okay, so all the lines are parallel coming in. If you've forgotten what parallel means, it means they're never going to meet those lines. If I drew them on forever, they would never cross over. Okay. Now, when they reflect off, because of the surface that it's reflecting off of, they all reflect off at exactly the same angle again. making sure they're still parallel to each other and enter our eye. That means we'd actually be able to see ourselves in this surface, and this is a mirror, so that makes sense, okay? So why is it that I can see myself in a mirror, but I can't see myself in the moon? Other than the fact that it's diffuse reflection from the moon. But why is it diffuse reflection? Because of essentially how smooth or, you know, not smooth the surface is. So mirrors are extremely smooth. The layer of water on a lake, that's very, very smooth as well. That's where you can see yourself. Things that you might think are smooth actually aren't that smooth. So for example, this whiteboard, I can kind of see myself in it actually. Can you see this bit there? That kind of looks like me. So you might think that a whiteboard's really, really smooth, but it's actually not as smooth as you might think. If I manage to get, you know, a really powerful microscope and go really, look really, really closely at the surface of this, you would see it's actually a lot bumpier than you think. Same as this desk here. The paper, it looks smooth, but it's actually not that smooth. Okay, now the moon is very obviously not smooth. It's very, very bumpy. And therefore, could you imagine that if this surface was bumpy and you're applying the law of reflection, which we talked about in the last video, then they're not all going to bounce off at those angles, are they? So I'll show you that now. So this is where I make up my surface. So let's do it over here. I don't know, it's just a random surface. Could be the moon, could be anything really, but a carpet, who knows. And if I draw my eye up here again, done it at a bit of a weird angle. There we go, there's our pupil. And let's draw my 3 incoming rays of light first of all. There's one. There's 2. I didn't quite draw that parallel, but let's imagine it was. There's 3. Now, hopefully you can see they're not quite going to reflect in the same way that they did here. So this is where I might actually need to draw a normal. So the normal to this tiny bit of surface here, this bit here. Now it's not flat like that. If you look at it carefully, it's actually kind of a little bit, or maybe not quite at that angle, maybe more like, I've just done it the same angle really, but it's not clearly flat. So actually it's not going to bounce off like here and enter the eye quite as cleanly as that. It's going to, the normal is actually going to go off in a, like that. So not quite like that, but at an angle like that. So actually, if I get this whiteboard, which I'm using as my ruler over here, then the reflected ray is, would you say that's about right? I think that's about right. It's actually going to go off here. Okay, now what about this one here? Again, can you see it's actually shaped kind of like that there? And actually that's hit almost dead on the middle. So that kind of is the normal itself. So it's going to go back along the normal. So it's going to go down here and then it's going to reflect directly back along the instant ray essentially. So I would draw that even thicker because it's going back along it. There we go, so it's incoming and then it's going reflecting back there. So we've got one coming off here, one coming off here. What's this one going to do? If I magnified that, this is what it looks like. Roughly. Can you see that section there? Kind of looks like this, and my incoming ray is actually coming, have I got that right? Kind of like that. It's coming in like that. So again, when this one reflects off, it's going to be a bit of a weird angle, and it's not going to all reflect straight back into the eye quite like it did over here for specular reflection. So this one is diffuse reflection. Now I've unfortunately made it so that none of those rays of light actually reflect back into the eye, so the eye's not really seeing it that well from this diagram. But remember, there's going to be more than 3 rays of light. There's going to be, there's going to be loads of them. So some are definitely going to enter the eye, but they're all going to enter the eye at varying angles, and therefore you can see that this object exists. I can see the moon, but I can't see myself in it. And I hope that kind of makes sense. And if not, obviously, ask your teacher or ask me directly, especially if I'm your teacher. Have I missed any core questions? No, there was only 3 and we covered all of them. So I hope that makes sense. Right, bye.